Example number 2 under quadratic functions, we're graphing, again, parabolas. So here's example number 2. Like most things, there's multiple ways this can be taught. There's two schools of thought about the standard form of a quadratic function. Some people will tell you that that form is standard. Others, myself included, would prefer that it be in the form of ax squared plus bx plus c. So on example number 2 here, you'll notice that this form doesn't match the form that I'm showing you. As I said earlier, others might show you how to graph this in a different way. I don't have time to show you multiple ways to do this, and in my experience, when you show multiple approaches, it gets confusing. So again, that's my philosophy here. So anyway, the point is we need to manipulate this to appear like that if we're going to do it the way I'm showing you. And so board space is at a premium. I'm going to bring this function down here, and so you could do it off to the side somewhere. And if we look at this, this is basically simplification of the form that we would have seen back on assignment number 4. So if we apply the order of operations to this, again, the proper way to square that quantity would be to write it out twice and distribute it. And again, I apologize for the fact that the board space is so cramped here, but that quantity x plus 3 squared, again, you'd write it out twice, and yes, I'll say the word FOIL it. So if you distribute this out, and again, I'm at a lack of board space here, but if we distribute that out, we would get x squared plus 6x plus 9, all right? First outer inner last, combine like terms. And then, of course, the next thing would be to distribute the negative 2 into the parentheses. So the point is, this is all simplification of the type that we would have talked about way back when on assignment number 4, all right, simplifying math expressions. So again, we're distributing the negative 2 into the parentheses. And then finally, these constants here would be like terms that we could combine. So again, if you take this expression off to the side and simplify it, as we did on assignment 4, it'll then become ax squared plus bx plus c, which is, in my opinion, the desired format. So, I'm going to replace that function up there in its original form as negative 2x squared minus 12x and plus 32, all right? So there we go with that. And I would like to think that that would have been a pretty straightforward thing. So if it doesn't match that format, ax squared bxc, I would recommend you take it off to the side and simplify it, like example 4, and foiling, distributing, and so forth. So, now we're good to go, in my opinion. So again, I would recommend that we identify the fact that A equals negative 2 on this question, and B would equal negative 12, and C would equal 32, and now we can just cookbook our way through this as we did on example number 1. And once again, I highly recommend that you watch these examples in order, all right? So once again, we're looking at example 2, and now we'll go through the steps. So the axis of symmetry would be, in this case, x equals negative b, which is negative 12, divided by 2 times a, which is negative 2. All right, negative, negative, the numerator becomes positive 12, the denominator becomes negative 4, and then 12 divided by negative 4 is negative 3. And as we harped on example number 1, x equals would be imperative that we put that there. All right, so actually on the remaining examples, I'm going to leave up here in red what would be the same on every one of these. So x equals negative 3, which would indicate that we would go to negative 3 on the x-axis here. All right, and I'm going to scale the x-axis by 1s, therefore. And therefore, that'd be negative 1, negative 2, negative 3. And it looks like this would be our axis of symmetry. I want to remind you that x equals a number is a vertical line. You locate that number on the x-axis and draw a vertical line. That's why it's so important to put x equals. All right. And then the vertex would be an ordered pair, and we can immediately dump that value into, I'm going to put the fact that this ordered pair would be parentheses, comma, right? And we always dump that value of x in here. Our ordered pair is going to be -3 something. And then in this case, we would put -3 into the function for x, and therefore that would be -2 times -3 squared minus 12 times -3 and plus 32. All right, now, again, I hate to use this as an excuse, but I have less board space than I normally would. So when we get to these things that are mechanical arithmetic, in the interest of space, we're going to have to say, hey, look, that's just the order of operations, crunching those numbers. And that's assignment number 1. All right, so we've got to be able to run through this. The deeper we get into the semester, the mechanical steps, we have to run through them quickly. But this would be, you would square the -3 and get +9. +9 times -2 is -18. -12 times -3 is +36. And then the plus 32. And then continue on, and this turns out to be 50. All right, so that would be 50 there, and that will be our vertex, that ordered pair. And please, when you do these questions, make sure you put your parentheses and your comma there to indicate that that's an ordered pair. Given that value of y, I think that a y scale of 10 would be reasonable. And again, I ask that you identify the scale that you're using when you graph these. All right, and so if we're going to find 50 on the y-axis, that'd be 10, 20, 30, 40, 50. That'd be 5 boxes. You know, again, you don't need to put the numbers on here if you identify the scale for us. And so that ordered pair, x is -3, y is 50, in this case would be right about there. All right, that's that vertex. So now let's talk about, is that the lowest point on the graph or is it the highest point on the graph? What direction does it open? And I want to remind you that has to do with the value of a, which in this case is -2. And since -2 is less than 0, this parabola will open downward, won't it? And you might think, well, what good does that do? We're going to talk later about, in fact, let's talk, well, we'll get to it in a minute. In my opinion, that's going to help us figure out whether we even have x-intercepts in the first place. See, if this graph would have opened upward, this graph would never hit the x-axis. The point is, it's very possible that you don't have x-intercepts. But I get ahead of myself. We'll talk about that a little bit later. All right, a y-intercept is an ordered pair. It's a point, parentheses, comma. Again, I'm putting in red what would always be there. And a y-intercept is always 0 something, always. And so, if we go plug 0 in for x, these two terms that have x basically disappear, and wouldn't y equal 32 sticking on the end there? So for this question, that's pretty easy. You put 0 in for x, and y will be that number sticking out there, 32 in this case. So again, remembering that we scaled the y by tens, 10, 20, 30, a little bit above 30, this would be the ordered pair, x, 0, y, 32-ish. All right? So, again, I'm trying to get these markers to work a little bit better, and that's why I'm shaking them here. All right, so we've got that. Now, what I got a little bit excited about earlier, x-intercepts. We will see more examples of this later, but I always tell people to make sure you have x-intercepts before you go looking for them. And I don't have a math formula for that. I have logic. That's why it says points if any. I'll say it again. If your vertex was here and it opened up, this would never hit the x-axis. And you visualize that and you'd say, it's not going to hit it. But it opens down. So if this has a vertex up here and it opens down, I hope it would stand to reason to you that this is going to hit the x-axis somewhere over here, and it's going to hit it somewhere over here. So I would reserve for this question 2 spots for those points, one over here on the right of the axis of symmetry and one over here on the left. There are going to be 2 of them. All right? And all all points on the x-axis have a y value of 0. So these are going to be both ordered pairs where y is 0. You need to remember that y and f of x are interchangeable, so the point would be, we're going to put 0 in for the function, because that's the y. So that creates the equation 0 equals negative 2x squared minus 12x plus 32, and that's a quadratic equation, which is assignment number 11. So then you go back to assignment number 11 and do the things that we talked about when we solved quadratic equations. All right, so there's your flashback here. Doodly-doo, doodly-doo. And I would point out this particular equation is already in standard form, so the hope will be that it'll factor, and if it doesn't, we'll do the quadratic formula. So you go back and do assignment 11 would be the point here. Again, space is at such a premium. I'm so sorry for having to cram this work in here, but this is indeed review. So I believe in this case we could factor out negative 2, which then becomes x squared plus 6x minus 16. And then it looks to me like that trinomial, in this case, yay, it factors. It'll factor as x plus 8 times x minus 2. And then, again, I've looked and looked, I've tried to find space for this, but if you set that one equal to 0, you'll get x equals negative 8, because wouldn't negative 8 plus 8 make that expression 0? And then what value of x would make this one 0? 2. 2 minus 2, right? So we have two values of x, the 2 points, all right? So this ordered pair would have an x of negative 8, and this would have an x value of 2. And then we go plot those. So negative 8 on the x-axis. So I need to extend that out here. We're going by ones, right? Negative 1, negative 2, negative 3, 4, 5, 6, 7, 8. My scale's kind of messed up here. All right, I'm going on the fly here. I don't have my graph paper board like I would way over there. And then 2, 0. 2, 0 would be this ordered pair. And one nice thing about symmetry here is that if you count from the axis of symmetry, this ordered pair is 1, 2, 3, 4, 5 units to the right, and this one's 5 units to the left. So those should be evenly spaced around that axis of symmetry. And they are. They're both 5 units away. Yay. All right. And then from here, we can just graph this thing and just make sure your graph hits your points that you've determined. And there we are. So that's what we're looking for on these questions. If you could please go through and identify A, B, C, D, E, and then of course, use that information to create the graph. So that's the format that we're following on these examples, and it's the format I would ask you to follow when you graph your parabolas on assignment 22. Again, I hope that all made sense. Good luck to you. We'll come back and enjoy, I think, 3 more. All right.